G'day guys. This is going to cover an area of interest to me, PUFA, and animal PUFA in particular, and its effects on bones and stuff like that. So let's get into it. Let me just share the screen. So this is on piglets, dose response of bone mass in dietary arachidonic acid in piglets, fed cow milk-based formula. So basically, study confirms the dietary arachidonic acid alters bone mass and clarifies the best amount of arachidonic acid to be added to the diet of pigs born at term because the amount of dietary DHA was held constant, whether the other amounts of DHA related to bone mass require investigation. So they're basically saying we increased the actual arachidonic acid and we saw increases, as you can see here, bone mineral content. The more arachidonic acid, the higher the bone mineralization and also the bone mass. So that was on piglets. Okay, let's move on. There's another study covering arachidonic acid as well. And again, this is in an animal model. Obviously, we can't experiment on humans, which is annoying, but it's the way it is, whether we like it or not. Dietary PUFA and exogenous prostaglandins too. So obviously, you know that you need arachidonic acid for prostaglandins. So just covering that, and this is about arachidonic acid. So, okay, and part of the mechanism behind response of bones to PUFA is due to reduce bone reabsorption, and the response of exogenous PGE2 is linked to the enhanced osteoblast activity in vivo. It has been theorized that PUFA elevate bone mass as a result of change in PGE2 metabolism, and because of the strong data supporting the positive relationship between the exogenous PGE2 and bone mass. This is the first report of independent and combined effects of PUFA and exogenous PGE2 on bone mass and bone cell metabolism. So what we've actually shown is that both arachidonic acid and prostaglandins, so E2, so we call it for short PGE2, independently of each other are basically the increasing bone mass. Dietary PUFA provided as arachidonic acid and DHA reduces bone reabsorption as expected based on urinary in telepeptide excretion. Exogenous low dose PGE elevated osteoblasts, okay, activity as anticipated based on the plasma osteocalcin concentrations. Plasma osteocalcin is thought to reflect osteoblast activity and thus may indicate bone formation and mineralization. PGE also reduced excretion of calcium, so also had an effect on reducing calcium loss. Taken together, high osteocalcin and lower calcium excretion suggests elevated bone formation and mineralization. Through these distinct effects on bone cell activity, both treatments resulted in elevated firmer mineral content. So blah, 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 blah. Anyway, I'm not going to go through the whole fucking study. So what these studies are actually showing us is that arachidonic acid improves, and prostaglandins E2, and these are, you'll find these things in animal foods, and also arachidonic acid is important in basically that pathway. It shows quite clearly that it is involved in both the bone mass density, but also in mineralization as well. So it doesn't surprise me. I mean, if you're building bone, mineralization is going to be an important factor in that as well, plus collagen and all that sort of stuff. So what I'm going to do is I'm going to look at diets and what the sources of arachidonic acid. So we will look at, let me just go to this. Okay, so this is looking at the US population changes in omega-6 and omega-3s. I'm not really focused on that. Let's just open this. So just to clarify things for everyone, I'm looking at linoleic acid and alpha linolenic acid, arachidonic acid, EPA, DHA, and okay, the seafoods and tea foods. Okay, so basically we're looking at current and traditional. So what were in the diet in the beginning of the 20th century. Okay, so with current milk, arachidonic acid is pretty much DHA and all that. And that's due to, this is all due to pasteurization, obviously. So you pretty much lose everything, basically. So the only things that you do keep are basically a bit of linoleic acid and a bit of alpha linoleic acid, linolenic acid. And so the whole milk, which is basically the traditional, obviously it's got more LA, which will be converted to arachidonic acid. Very little extra of that. Doesn't have a lot of DHA or EPA or anything like that, and has very little in that regard. So it's not the best source. Obviously, animal foods are going to be a better source. So when we're looking at also traditional levels, when it comes to ground beef, there's not much difference. Where the differences are is slightly in the EPA and DHA, a lot of factors in that, but there's not vast. The only thing is that what we do see is an increase in LA and DHA, and the problem is they probably put it in the feed, and it's only in the feed, basically. Pork is a pretty good source of, so that's current, that's traditional, very good levels of both. The current has got far more ALA, about, compared to and also greater arachidonic acid. So that only becomes an issue if the conversion pathway is affected in any negative way. So otherwise, it's not really a problem. Same goes for bacon. Traditional bacon had more arachidonic acid and less linoleic acid. And that again is the sort of modern food system. But again, I don't see it as a problem. Chickens on the other hand, have more arachidonic acid, and pretty much the current chickens and the older chickens have the similar levels of linoleic acid compared to traditional pork and their traditional cells as well. So it's not much difference. Turkey's got a bit more, and their levels are fairly similar. Actually, the current one has got a bit more when it comes to arachidonic acid. So it seems like the poultry, sort of, we always get a lot of talk about the poultry is really bad when it comes to sort of PUFA and all that, but not really the case in that regard. So I think it's way overstated. But as I said, I don't have a problem with PUFA from animal sources anyway, so that doesn't bother me as long as you've got good conversion levels. The key thing is, my biggest concern with you know, the alpha linolenic acid levels. Obviously, these aren't that high, so we don't really have to worry. Basically, they're not, you know, multiple fold, as I will show shortly. So eggs are a pretty good source. Traditional ones have more, current ones have less. Again, also DHA, traditional eggs, so pastured will be best in that regard. The same goes for traditional sort of levels of butter and stuff like that. But that's not that, you know, the focus isn't really on that. Obviously, when we're looking at things like lard compared to, it's got far more LA. And the reason for that is, that also explains the reason why when it comes to beef, tallow has more deuterium, where lard has less deuterium, obviously because it's got more LA, and all PUFAs in animal fats are lower in deuterium. So that's another important acid to be remembered. So I'll just get rid of that for a sec. So now let me go over to these. As you can see, the things like corn, sunflower, sesame, olives don't have a lot, as you can see. Remember, the other one was in thousands. So when we're, pork and olives are very similar. This is, so just to know what so basically, when we're looking at that amount, we're looking at very low, like 2 grams. And when we're looking at these, we're in the grams. So we're talking about 8 compared to 2, in the animal products or whatever. So in the plants is substantially more per 100 grams in a sense. And when we're looking at, soybean, cottonseed, it's massive. And remember, these are processed things, and so they're quite nasty. Coconut, quite low. Butter, similar to lard. Similar to tallow and stuff like that. And some of the pork products as well. Palm oil a bit more than olive. Palm kernel, much lower in that regard. So it's probably why a lot of people that are health conscious buy red palm oil, as it's called, as well, which tends to be a bit on the lower from standard. Or almonds a bit higher, but again, as long as they're not oxidized, it's less of an issue. Walnuts are pretty high, but I'm not really concerned about the LA. I'm concerned about the ALA. If it's higher, like, what are the major things that we consume? Soybean, it's got a high ALA. Now, the veg tarts will tell you that's a good thing. It's the plant-based omega-3. Rapeseed oil, much higher. Yes. And walnuts as well. What does that mean? Well, let's take a look. Activities of desaturates, particularly delta-6 desaturates, the first enzyme in the synthesis of long chains or more unsaturated fatty acids. It acts on ALA and LA, that pathway. Yes, yes. Are still to be elevated, but they are very much less immediately after birth. I'm not talking about animals here, especially zero in the brains of animals. Their activity in the liver was greatly reduced, blah, blah, blah. As a result, DHA comes either from hepatic transformation of dietary ALA or directly from the diet. So now, little DHA synthesized at the blood-brain barrier, but some may be produced in the cord. Anyway, now this is we're getting into the more crux of the thing. So rate of conversion may vary according to sex, age, pathophysiological conditions, blah, blah, blah. Delta-6 desaturates activity is reduced in older rats fed a diet containing ALA. So ALA is actually reducing that conversion method, but is not in rats fed an ALA deficient diet. Delta desaturates activity does not only change with age, but it also is influenced by polyunsaturated fatty acid content of the diet and to the omega-6, omega-3 balance. Rats given an ALA deficient diet and then refed to normal sufficient diet recover only partially the activity of the enzymatic conversion. So basically what we're looking at is that we know that ALA is converted to DHA very poorly. It's well understood and all that. But it seems it also has a negative effect on, this enzymatic pathway. So it's not a good thing. So vegans that are basically consuming a lot of that are going to find it much harder to convert LA to arachidonic acid. And arachidonic acid is where the game is, as I've pointed out. That's the thing that actually helps, with a whole lot of health areas, improving cellular function, and, supporting the immune system, supporting repair mechanisms and all that. It's probably another reason why vegans break down and all that. They're affecting. It's probably something similar that's happened, like the Randall cycle where you've got too much sugar and fat and it blockades those mechanisms and sort of, has an effect. Luckily, if you ameliorate that, it recovers fully. In this case, it doesn't actually seem to recover as well, which is a concern. It should be a concern very much on those on the plant-based diet, in particular when it comes to the essential fatty acids and conversions and issues like that. The question here is, as I've always pointed out to people, what we don't want a lot of plant-based ALA. That's another reason to be on a species appropriate diet eliminates that problem. And the major sort of sources that people consume are soy, rapeseed, and certain nuts and stuff like that, which tend to be higher in ALA. And one, we can't convert it very efficiently or very poorly, the majority of people, the overwhelming majority of people, let's be honest. But then it also affects that prime conversion mechanism, which is a problem. We want to take the majority of our ALA and push up arachidonic acid. And we know that basically arachidonic acid levels in vegans and vegetarians is much lower. And they think that that's great. But that's because they've got the diluted view that arachidonic acid basically causes inflammation. It doesn't. I mean, bodybuilders have been using arachidonic acid for some time to build stronger bones and stronger tissue. They know it works. If you're going to on a skeletal structure going to put basically more tissue, you need stronger bones, and they know it. And that is why they prioritize foods that are high in those sources. You know, the ones that are cluey, that are really up to date with the science. Those who aren't, basically, you know, avoid those foods. But it's the reason why people eat so much poultry and stuff like that, and eggs, for those reasons, to get more arachidonic acid. You know, a lot of that's been lost in that community, because, you know, that was old research done in the 60s and 70s, and pretty much the bodybuilders knew about it then. It remained within the bodybuilder community, but the knowledge was actually lost why they're eating these foods. So there's a whole lot of different reasons. Anyway, now let's just look at the sort of foods and stuff like that that we're actually looking at. Okay, well, let me just share that. Now, when we're looking at, you know, things, good sources, best source of arachidonic acid, lamb's brain, lamb kidney, lamb liver, lamb heart, beef, sweetbreads, lamb, beef, and franks. There are others that are pretty high as well that are not covered there, and they tend to be basically, when we're looking at the animal, the poultry. Poultry is quite high. So turkey and chicken is much higher than beef, unless you're looking at liver. But I tend to not promote too much excessive consumption of liver, primarily because you'll end up with too much copper. Okay, so a bit of liver, not a bad thing, but excessive could cause, you know, add too much, because it's much higher in copper, and we want to have more zinc to copper in general. A bit of copper foods is not a bad thing. Crustaceans and stuff like that tend to have a better balance, so including some of those things, but we don't want to overdo the copper. And also, you know, some people may have concerns about retinol and stuff like that. I'm going to cover that in a more, soon, in a more detailed way, because there's been a lot of talk about that, and sort of demonstrate why there are concerns at certain levels. But generally, a general carnivore, what they consume and all that, is fine. Even if you were to consume a bit of liver here and there, is fine. If you were to basically go on an all liver diet, it would be a problem, but that's for another day, for another conversation. But these sort of things that do have good levels of arachidonic acid, obviously some of the actual foods, also these foods also have good levels of linoleic acid. And as long as we're not affecting that pathway, and this is really important, guys, as long as we're not affecting the pathway in a negative way by consuming, too much alpha-linoleic acid, then we don't really have a problem. We're not going to really be impeding that conversion system. And usually people that are on a carnivore diet tend to have higher arachidonic acid levels, which is really good to support all sorts of things: repair, bone mineralization, bone mass, and all sorts of wonderful things, and to support a healthy immune system and repair mechanisms. So it's something that people on a veganerized diet will tend to have a problem, both with the conversion and also the inhibition of too much ALA, which is in a lot of those foods that they primarily consume, and they're unaware of that in that regard. what they need to do is what we do. We basically get our omega-3s from animals that primarily furnish us with those things, with DHA and EPA. So getting a bit of fish in there, getting a bit of grass-fed animals, which tend to have, you don't need a lot when it comes to, to omega-3s. Remember, omega-3s are not oxidized. You can't oxidize omega-3s. They primarily are useful in the brain and a few other tissue, the eyes and a number of other areas that are important, but they're not, in a sense, the dominant one. Even in the brain, there is slightly more, omega-6 to omega-3, PUFA. So even the brain has more omega-6, animal-based omega-6, than omega-3s in the brain. I know everybody talks about the omega-3s in the brain, but there is more omega-6. Then you've got in all the tissue throughout the rest of the body, you've got quite a bit of omega-6 as well, which plays a whole lot of reparative roles and all that. So our bodies do need slightly more omega-6s. That's the reality. And as long as they're getting them from a source that is a healthy animal source, and they haven't gone through an industrial system, one which actually adds a lot of, it affects the hydrogen bonds and actually ends up adding a lot of deuterium. And the other thing is it hasn't actually damaged those fats and all that. As you know, if you check my other video, you really need to cook animal fats like lard for 35 hours. Otherwise, if you just cook them for a couple of hours even, you're only going to get trace levels, where with everything else, you don't even have to cook basically seed oils. You just have to leave them exposed to a bit of oxygen and they will become so rancid and so toxic. So, there is a fundamental difference between animal fats, plus the importance of, we don't have to care about ratios. We leave that conversion system intact for LA to be converted to arachidonic acid. We don't have to basically worry about omega-3s. We get them in the diet. So it's an irrelevancy for anyone on a carnivore diet or on a low carb diet of most types. Even probably some of the omnivore, those who are, on a standard diet, probably don't really have to care as much in that regard. Their biggest issue isn't so much, it's the source of their omega-6s. And their biggest issue of those sources are basically from seed oils, which are quite toxic and damaged going through a refinery, so that's their main issue, and they can be quite damaging to their tissue rather than being beneficial. So that's pretty much it. Do not fear omega-6s from animal sources. They are very useful and they are very stable, and they don't cause any harm. It's only the seed oils which are the problem, and we need to point that out and keep on pushing that point, And when they look at studies about, bone health and muscle health and all that are shown in a negative light, when you actually look at what the source of the PUFA was, it always is these seed oils, these damaged seed oils. So we need to point this out. And that's why I always challenge people. I say, show me a study that shows something different and I will reconsider. But they can't find any, because we know what they are. They're all studies based on, even when they're doing with rats and all that, what do they give them? A whole lot of seed oil. We know what it is. It's like that other study that I showed you ages ago, some time ago, where the rat was induced with cancer. They gave it bacon, not an issue. It actually was protective. It actually was protective against the induced colon cancer. Real food that comes from animal products isn't going to be an issue. It's what we've been consuming for millions of years. The N15 data actually supports that quite clearly. The issue is basically the stuff that we no longer put in our system, luckily. It's the sort of stuff we need to point out to other people. When they demonize or PUFA, we need to quite clearly differentiate the two groups. They're not the same. Anyway, I hope you enjoyed this one on animal PUFA. See yous.